Let's begin. Today's December 26th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria cards 1, 6, 17, 19, and 21. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, and finally criteria card E. Criteria card A takes a look at our first digit, the triangle digit, and the Turing machine will be comparing it to the number 1. Should triangle be equal to 1, or should triangle be greater than 1? Criteria card B will take a look at our middle digit, the square digit, and the Turing machine will let us know whether it's an even digit or an odd digit. Criteria card C will take a look at our 3-digit solution, and the Turing machine will let us know how many evens there are. Are there no evens? Is there a single even? Perhaps 2, maybe even all 3 are even. Criteria card D, again, will take a look at our first 2 digits, triangle and square, add them together, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card E, again, takes a look at our 3-digit solution, and the Turing machine will let us know whether there's a pair or not. If there is a pair, let's look at the example of 131. Alternatively, if there is no pair, there are 2 scenarios. One where all the digits are distinct, as in the example 134, or all the digits are the same, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 5 criteria cards we just described. And we're going to start off with an initial proposal of 314. So the first thing I think I'd like to test is criteria card B. Okay, so the Turing machine does not approve of my choice in square. I did pick an odd one, and since the Turing machine does not agree with that, it's letting us know that square should actually be even. So let's go ahead and type that up in our notes in section B. And that is, again, that square is an even digit. And since it is even, let's go ahead and cross out the 3 odds. Okay. I think the next thing I'd like to test is criteria card D. Okay, so the Turing machine does approve of my choice. I did pick a 3 for triangle and a 1 for square. Its sum is 4, and 4 is less than 6. And yeah, the Turing machine agrees with that. So let's go ahead and type that up in our notes in section D. And that is that triangle plus square should be less than 6. And so what does that inform us? Well, if we want to restrict the sum of the first 2 digits to be less than 6, neither triangle nor square can be a 5. So let's go ahead and cross out the 5 in triangle. And the reason for that is when you add 5 even to the smallest of 1, you already know that that sum is 6. And obviously anything bigger than 1 would only give you something greater than 6. Both of those cases are not valid now that we know that the sum of the first 2 has to be less than 6. So what else can we say? Well, again, 5 doesn't work, and I believe we can even cross out triangle 4, because when you add 4 to the smallest of 2, that's 6 already, and that obviously is not valid. So yeah, we can even cross out the 4. Now, this 4 in square is still okay because you can still add it to a 1. So that's possible. And yeah, 3 is okay because you can add it to 2. And yeah, there are a lot of cases still that are very much in play. So let's see, the next thing. So we already know we have a single even. We know you can't have 0 even. What else? I don't think you could have 3 evens, because if you had 3 evens, you would know that triangle would have to be greater than 1, making, I think, this card irrelevant. I think that is a sound argument, right? Because if you knew you had 3 evens, you know triangle can't be a 1, so it would be greater. So I think it's either between 1 and 2 evens. And let's see, anything else? Well, let's see. Let's go ahead and test criteria card E. Okay, so the Turing Machine does approve of my proposal 314. Notice 314 has no pairs. So, and the Turing Machine approves of that. So yeah, we'll say that the solution has no pairs, and that basically means that all our digits must, well, I was going to say that they all have to be distinct. We haven't established that yet. We'll just say that the solution has no pairs. Okay, so if the solution has no pairs, we have 2 scenarios, one where they're all different or all the same. So what would that inform us? Can we deduce at this point? Well, the only possibility would be 222, because that's the only digit that has nothing crossed out. Everything else has at least one item crossed out. So could it be 222? Oh, well, it can't be 222 based on the argument we made earlier, in that if we had 3 evens, we would know that there could be, triangle cannot be a 1. So I think for that fact, you can't have 222. Yeah, so you can't have 3 even, so you can't have all 2s. I think that's sound. So I think it's safe to say that they should all be distinct. And okay, well, that does it for this round. We have completed our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So the only 2 criteria cards we did not test were criteria card A, comparing that first digit to the number 1, and establishing how many evens there are. And everything else, the other 3, we were able to either deduce or, figure out. So yeah, it just comes down to A and C. So let's see. What if triangle were 1? I think if triangle were 1, there might be too many ambiguous solutions, because both 1 works both with 2 and 4. So we could pick 1, 2, 4, or 1, 2, and then obviously it couldn't be 1, 2 because of the no pairs. Well, I guess 1, 2, well, it couldn't be 1, 2, 3 or 1, 2, 5, because in both those cases you would have a single even. So you wouldn't be able to distinguish between 1, 2, 3 and 1, 2, 5. So, but you could have 1, 2, 4, because that has 2 evens. Let's go ahead and start maybe typing some of these possibilities out. So 1, 2, 4 seems to work out. And let's see, what else? Yeah, because there's no other way to distinguish between 3 and 5 that I can tell. All right, And I believe that might be, well, again, we're just talking about triangle 1. So you could have 1, 2, 4. What about 1, 4? 1, 4. Well, again, you can't have a 1. You could have a 2. That might work. But again, I don't think you could have 1, 4, 3 or 1, 4, 5, because those would be hard to distinguish between, with all the criteria cards. So I think you can exclude 1, 4, 3 and 1, 4, 5. Now, that said, I don't see how I can distinguish between 1, 2, 4 and 1, 4, 2. Because now in these two cases, you do have 2 evens. And you do have that 1 in triangle. And there are no pairs. So yes, I would even say that I can't distinguish between these two. Okay, so that, I believe then we can cross out the 1. And so I think we can safely deduce, I'm going to type it up, that we're going to deduce that triangle must be greater than 1. Because none of the options that started with a 1, or I should say that all of the options that started with a 1 with triangle led to ambiguous solutions. So we're going to deduce that triangle is actually greater than 1. Okay. So that leaves us with 2 or 3 in triangle. So let's see, we know we can't have any duplicates. So if triangle were 2, it forces us to choose 4 for square. And I think we're back to that same dilemma of how do you pick between 1, 3, and 5. The 2s and 4s you can't have because you have no pairs. So 2, 4, 1, 3, 5, I don't see how you can pick, because all those have 2 evens and then you have a single odd. So I don't think you could have a 2. So it looks like you're going to have 3. And then now we're down to 3, 2, 4, 3, 4, 2. But you can't have 3, 4. Oh, look at that. Because the sum has to be less than. Interesting. Okay. So we're down to 3, 2. Now you can't have 2. Oops. You can't have 2 because of the no duplicate, and you can't have a 3. And I think we're down to the same case of how would you pick between 1 and 5? You can't just have a single even, so I think it's going to be 3, 2, 4. Wow, have we actually come up with a solution of 3, 2, 4? Well, let me go ahead and type it up. And in C, I'm going to type that we're going to deduce the solution has 2 evens. Okay. Wow. Well, if these deductions are correct, then we've got our solution in just one round. Very interesting. Okay, well, let's give it a try. 3, 2, 4 as our solution. 3, 2, 4. Incredible. Well, what about that? Look at that. Wow. I don't recall solving a puzzle in just one round. Yeah, yeah, nothing comes to mind. Well, obviously, I'm pretty sure, very confident that we beat the Turing machine. It is a 5 criteria card puzzle, and we only did 3 tests. Incredible. Well, let's go type that up. So we did B, D, E, and B was the only incorrect. So let's go ahead and type that up. So B was incorrect. D and E were both correct, and we outright deduced A and C. Look at that. 1 round, 3 questions, and the Turing machine took 2 rounds and had to do it in 6 questions. Well, no doubt, very interesting. So obviously, the power of, I won't say trial and error, but yeah, do play out, all these different scenarios. Now, we could have, obviously tested A and C just to make sure, but, if you're meticulous, if you're careful, and you plan out, yeah, these possible solutions can happen. Well, what about you? How did you solve it? What criteria cards did you choose? And did you discover anything interesting? Please add your thoughts to the comments. If you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe so that you don't miss out on any future videos. Well, until next time, have a great one.